Okay, hello students. Today we're looking at sketching linear graphs using gradient and y-intercepts. So that's what we want you to do. You should be able to sketch linear graphs by using the gradient and y-intercept after this lesson. So to sketch a linear graph you need a minimum of 2 points. Generally 3 to prove that it is a linear one, but if we tell you that it's linear, you can just use 2. Now once these 2 points are plotted, you can rule a straight line through them. Now one way to identify 2 points is to use the y-intercept. Now remember, the y-intercept is where the graph crosses the y-axis on the Cartesian plane. Now the other one is the gradient. So if you know how far you go up for every number you go across, you've got the gradient as well. So this is our gradient intercept method. So in the gradient intercept method, a point is plotted at the y-intercept, and then the rise and the run identified from the gradient can be used to locate the second point. Now the general rule for a linear graph is y equals mx plus c. I think one lesson I told you y equals mx plus b. It doesn't really matter. What matters is this m value here and this plus term. So this here in y equals mx plus b, that's going to be the gradient. And we learnt last lesson how to calculate the gradient. And in this one, this is going to be our y-intercept. So let's have a go at actually doing this, hey? So a linear relationship has a y-intercept of 5 and a gradient of 2. So what did we remember? Y equals mx plus c. So I know it's going to be a negative, a negative half, yep. And I'll rewrite that because that's a bit hard to see. Y equals negative half x plus, in this case it's a 5. So that's what we know. And what do we say? That this is a gradient and this is our y-intercept. And the y-intercept is where it crosses the line. So what do we want to do? We want to identify the rise and run from the gradient and then draw a sketch of the linear relationship using the gradient intercept method. So let's just think about gradient. We said that gradient equals rise over run. In this case we've got negative half. Now the best way to think about this is, negative 1 over 2. So what does this mean? We've got a negative 1 rise. So that means we go down 1 for every 2 we go across. Does that make sense? So if I'm thinking, if I've got here, I'm going to go down 1 and then go across 2. So the slope of my line will look like something like that. Okay, what else do we want to do? And identify the rise and the run from the relationship. Then we actually want to draw a sketch of the linear relationship using the gradient intercept method. So over here, what do we say? I'll have a look at my equation again. Y equals negative half x plus 5. So this plus 5 term is now the important one to think about. So let's go here. Plus 5 there. So what do we say? That this is our y-intercept. And then let's calculate our rise over run. What did we say? It was going down 1 for every 2 we go across. So we go down 1 and across 2. So that's the next point. Down 1 and across 2. That's going to be the next point. Down 1, across 2. Down 1, across 2. Down 1, across 2. Now we can just draw our line in, so with a ruler. And not very nice on OneNote, but we're getting the job done at the moment. So we have now drawn our, what do we call it? Our sketch of the linear relationship. And last of all, let's just write our equation in. So y equals negative half x plus 5. And that's our linear function, and that's our linear graph. Let's have a look at the next example. Sketch a graph of y equals 2x, take 4 using the gradient intercept method. So I'll just have to take a copy of that one. And let's give it a go. So what do we say? Y equals, do this at here. Oh, this is a bit of fun. 2x take 4. 2x take 4. So my gradient now is rise over run. So we'll actually, I want to do this one first. So it's crossing the line at -4. So that's this point here. So y equals 2x plus 4. Now let's think about this m term. So our gradient equals 2. Now that's 2 over 1. So remember, so we have a rise over run relationship. So in this case we're going up 2 for every one we're going across. So up 2 across 1. Up 2 across 1. Now you don't need to draw these steps in. So 1, 2 across 1. So you can see 1, 2 across 1. Now it's best to draw this in with a line. So 1, 2 across 1. And then we just draw that in. Wonder if this works if I try this. Not really. So let's sketch our line in. Oh, that looks like a dog's breakfast. Sorry, students. But you can see that we have a linear graph here, and we'll just on the line write our linear function y equals 2x plus 4. Is that all the question asked for? We can also look at the intercepts, can't we? And we can say, well, this point here is our y-intercept, and this point here is our x-intercept. So our y-intercept is 0, -4. Our x-intercept is 2, 0. Okay, look at the last set of questions here. For the rule, okay, write the rule for each linear graph with the given gradient and the y-intercept. So we said that y equals mx plus c, and we needed to recall that m equals gradient and c equals y-intercept. So that's my recall, and now I am just going to substitute into the linear function. So our first one is m equals 4, c equals -3. So we're just going to say, well, 4x take 3 for my first one. Oh yeah, that's good, I'm doing it correctly. And the next one is y equals, what do we got, -½ and then c equals 0. So I could say plus or minus 0, but that doesn't really make sense, doesn't it? So we just leave that out. Okay, that's your lot for today. Get into the mastery exercises, please, students.